So we're out here on the outdoor patio of our modern Sunset build, and you can see this incredible 55-foot span. How was that achieved? What's the design intent? And structurally, what are the components behind it? So we're out here at our cantilever patio again. In an earlier video, we talked about the butterfly roof system, the masonry, of course, which is a big part of the structural component. But now to achieve the 55-foot span, which we have here for the deck, this is really important about the structural steel. So you can see here we worked with alignment steel, and up here in the corner you can see this plate. What I really like about structural steel is that with wood frame, you know, anytime that you have beam to post, right? So think of a post to beam, there's a lot of configuration and hardware, right, to hold all that, from saddles and through bolts and other locking systems that really create that structure. With steel, it's almost a shortcut. You know, we have one saddle here that we'll show you, but in most cases, we just have to have a weld, you know, a really strong weld that's all inspected, third-party inspected. It's all designed from our steel fabricators and approved by our engineers. And so, for example, like you have here, a solid grout of masonry wall, as you can see, super solid here, and it has rebar, it has concrete, and as you can see up top, we actually have steel that runs through this entire structure. So this steel goes all the way through, so it really creates some strength going into the wall. And then on the outside, you can see it's just a plate here. So you have the plate that's attached, in other words, a steel embed. So a lot of times when you are working, you know, with the structural post, like we'll have here in the great room, when the concrete's poured, you know, and it's fresh and it's soft, they'll have the steel embed, and really the steel embed goes in to the concrete. It'll cure with the concrete, now it's solid, right? Think of like rebar in there, it's the same thing with the steel. It goes in, and typically you'll just have a clean plate. Then now we weld the plate to. So essentially you're not creating a ton of hardware like you can see here. We can run these massive steel structures all the way up. It's welded there in place, which now creates the strength for that 55-foot span. And then in some cases here where this has a 35-foot slider that fully pockets in here, you can see here that we have steel that runs in here, and there's a saddle. So what ends up happening is we set this column here. It sits in this saddle. We have some through bolts. This gets welded in place. Now this will allow us to have a transom up above. Again, we have minimal meat in this entire width here, you know, 55 foot with no structural component on the outside. On the inside, the reason that we do have a little structural component is just because for sound, and you don't want glass on this entire wall, so we wanted to break that up a little bit. So then on the kitchen area, we can have a smaller multi-slider that pockets in the wall, and then this one that's a little bit bigger that now can pocket on either side. And so these structural components are really important with the steel as we're working through those embeds, that now we have less structure, less meat there, which creates more views, more accessibility for the entire design of the house, and again, doesn't waver or eliminate any of the security from having these large openings. And you'll see here, as we went through this structure, one key component is the design aspect, right? We wanna have these super tall doors, you know, 10-foot doors that open up. But again, even though 10 feet gives you great views, we have this butterfly roof out here, you wanna go even higher, and so we have a transom up above. Well, the best way to do that is we have the I-beam. You can see that sitting on top of the masonry back in here, and that's all in place. That goes all the way through this width of 55 feet. So this I-beam comes all the way across, and then underneath we just have tube steel. So this tube steel is connected by a saddle here, which now gives us this transom, and it gives us this big opening. But more importantly, this is really a lot of coordination with our window company. Again, working with Benelli, owned by Pella. This is a very modern window, very thin profiles, all aluminum clad, thermally broken. And so now we can put in these aluminum clad windows, transoms, and there's a lot of work in templating. You know, the minute the steel goes up, we'll bring them out because these are all custom built to the exact height and width of this opening to optimize that. And that's really important because those it's long lead time. And when you think about the building schedule, the minute the steel goes up, we have to have those templated, especially with the supply chain where it is right now, 6 to 8 months out. You know, we want these windows in, we want them flashed properly, we want them waterproofed. You know, as we get through rough mechanicals, as we're preparing to enclose the entire structure and then get to drywall. But before we do that, we gotta have the windows in, because you don't want drywall installed in insulation and have rain or horizontal rain come in and hit this, even though we have a tall patio. So getting a jump on that, getting the steel up, making sure steel's coordinated with our framers. You know, for the truss system, make sure they're coordinated with our concrete company. They're hitting that schedule. it's a lot to coordinate, but it's super important because it now allows us to expedite the schedule.